All right, our notes today are talking mostly about the division property of exponents. All right, so the rule for this is represented here just at the front. If we've got two of the same bases, right, x over x, and we're dividing, then we get x to the power of a minus b. So whatever their exponents are, you subtract them. And the next one, we've got x to the power of negative a. In order to make that exponent a positive, we take the reciprocal of the term. So we're going to put 1 over x to the power of, now it's a positive a. Okay? The negative exponent doesn't make the number negative, it just flips it over. And then finally, right, we've got a negative exponent right now on the bottom, and it works the other way. So since it's already negative and we want it to be positive, we're going to write 1 on the bottom and x on the top, and now the a is a positive exponent. All right, but we wouldn't normally write that divided by 1 part of this thing, so in this case, we're just going to get rid of it. All right, so x to the power of a. Okay, this is very important. You are not done simplifying, I should have put that in there, until all your exponents are positive. So if you have some negative exponents in your answer, you need to keep going. All right, problems 1 and 2, we're using these rules up here. Okay, so for problem number 1, we've got a negative 3 for an exponent. Now we need to fix it and make it positive. Remember, imagine that we begin with a 1 on the bottom. That's something we wouldn't write. And now we're going to take the reciprocal. So we're going to have 1 over x, and now my exponent is a positive 3. Okay? Same kind of thing here. I'm starting out with a negative exponent, which means to make it positive, I'm going to flip this thing. So now 1 is on the bottom, and x to the power of 7 is on the top. And just like the formula, we wouldn't leave that 1 down there. So we're going to call this just x to the power of 7. All right? Okay, we're moving on to problem number 3. In problem number 3, we've got x over 3. Now we know that according to this rule, right, we're just going to subtract the exponent. So you probably already know that the answer is going to be x to the power of 8 minus 3, which is just x to the power of 5. However, I think it's really important for me to take the time to help y'all understand this. So I want you guys to think about it this way. If I have x to the 8th power over x to the 3rd power, this would be the same thing as saying 1, 2, 3, 4, 5, 6, 7, 8, all over x times x times x, right? We are allowed to cancel some x's out because we're multiplying everything, right? So it's allowed. So we're going to cross out every time we have a repeat. So top, bottom, on the top and on the bottom, and on the top and on the bottom, right? We got rid of all the extras kind of that we didn't need. And we're left with, just like we predicted, x to the power of 5. Okay? All right, in problem number 4, let's do it the long way here first. I would really like for you guys to really have this hit home. All right, take a look at this. We're going to rewrite the problem, and we're going to write out all of our terms. So I've got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we've got 7 m's and 7 n's. And on the bottom we've got an m and then 9 of the n's. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, now we can go ahead and we can cancel. So we've got n, so top, bottom, top, bottom, top, bottom, top, bottom, top, bottom, top, bottom. All right, I ran out of n's on the top, so I have to stop. I have 2 n's left on the bottom. All right, we can do a similar thing here with the m's, right? I had an m on the bottom and 1 on the top. And that's all I can do, right? So I'm left with all of these m's here on the top. So our answer is going to look like this. We're going to have, hopefully we all know what negative 9 divided by 3 is. That's just negative 3. We'll put a 1 down here for a placeholder. And then we see that we have lots of m's on the top still. In fact, we have 1, 2, 3, 4, 5, 6 of them. And on the bottom, we just have 2 n's, so n squared. All right, and this is my final answer. All right. Now, my question to you that I would ask is, how did we know that the m's were going to be on the top? Right? They were on both sides, top and bottom. Why did it just end up on the top? And likewise, how do we know that the n's would end up on the bottom? okay? Because in our original problem, we had them both on the top and on the bottom. The answer to this question lies in realizing that they end up wherever there were more of them to begin with. All right, so for example, in my M's, I had 7 and 1. So yeah, the M's ended up on top because I had way more to start with. Okay, and by the same train of thought, if I look at my N exponents, 9 and 7.
Havana Watson.
Sorry, just
Havana
ignore this.
Watson, please report to the front desk. Repeat, Havana Watson, please report to the front desk at once. All
right, so we have 9 and we have 7. So it makes sense that the end would end up on the bottom because all the top numbers would cancel before the bottom ones did, right? Wherever it's bigger, that's where our variable ends up. And this brings me to the way that I normally teach this in class, all right? And I'm going to show you guys that. And I promise we won't spend this much time on the other problems. All right, so the 9 and 3 we already talked about, it's just a division problem, right? So this is going to give us positive 3 over 1. All right, and now we're going to look at our M's, and I want you guys to ask yourself the question, when you're looking at this variable, M, you're going to ask yourself 2 questions. First question is this: where is it bigger, top or the bottom? It's bigger on the top, so the variable stays on the top. And to find the exponent, you got to ask yourself by how much. So 1, where is it bigger? Okay, and we're talking about the exponent. Okay, and the second question we ask is by how much? All right, so when I'm looking at my M's, the top is bigger by 6. And then we can do the same thing with the N's, all right? We're going to look at the N's. We've got n to the power of 7, n to the power of 9 on the bottom. So if we ask ourselves, where is it bigger, we're going to say on the bottom. How much bigger? How much bigger is 9 than 7? 2 more, 2 bigger. So this is my final answer. Okay, all right, we're going to move on to problem number 5. And we're going to do this one much quicker. All right, first things first, get our line set up, and then we look at our coefficients, because this is just regular nice division. 18 divided by 3 is 6. We'll put a 1 on the bottom as a placeholder. And then we look at our A's, and we're kind of sad because they have negatives, but we can deal with this. All right, y'all, we're going to ask ourselves the same question. Where is it bigger? In other words, what is more, -2 or -7? All right, well, -2 is technically more because it's closer to 0, right? It's less negative, so I have more on the top. And then you ask yourself, how much more? How much bigger is -2 compared to -7? And the answer is 5. Then we have our B's here, B3 over B3. Well, if you think about how this would look if we wrote it all out, all of the B's would cancel each other, right? So the B's actually go away. Then we just have lonely C by himself, and nothing to cancel this out with, nothing to compare it to, it just stays the same. So our answer is 6a to the 5th C. Okay, problem number 6, here we go. First things first, right, let's take care of those coefficients. Now this time we actually end up with a fraction still, right? Because 3 divided by 15 is equal to 0.2, which as a fraction we know is equal to 1/5, right? And in your calculator you can hit math, enter, enter for that.
Havana Watson, please report to the front desk. Thank you.
Okay, so we're going to do 1/5 here, and then we're going to look at our x's. All right, we've got x to the power of 5, x to the power of 3. Where is it bigger? It's bigger on the top. By how much? By 2. And then we look at our y's. Y to the 4th, y squared. Where is it bigger? Bigger on the top. By how much? Again, by 2. And now we're looking at our z's. Okay, where is it bigger? Well, we know it's bigger on the bottom because 2 is better than -1. But how much bigger? Well, think about a number line. If I'm here at -1, how far away are they? Like, how much bigger is this? Well, I've got to go 1, 2, 3. It's 3 bigger, right? 2 is actually 3 more than -1. Okay, and that's my answer. On a test, you probably wouldn't see this 1, but you already know that. All right, last but not least, what if you get this rule, this division rule of exponents in a word problem? Well, if this happens, it's probably going to be an area of a rectangle problem. So I'm going to draw a picture here. Okay, I'm going to put my area inside because that's where I usually label area. We're going to finish reading the problem. Find the height. We don't know the height. if the base is 4xy squared. All right, well, we're missing this side right here. What we know is that 4xy squared times this would give me my area. So if I need to find my missing side, I have to work backwards and I have to divide. All right, so let's set it up. We're going to take the area, right, because that's going to be the biggest term. That was our product before. We're going to divide it by the side we have, and this is going to give us the side that we're missing. Okay, all right, regular numbers in the front. 32 divided by 4, that's just going to be 8 over 1, right, as a placeholder. Next, I'm going to put a little 1 here on my x so I don't forget about it. And I'm going to look at my x's. All right. 2 questions. Remember, first question, where is it bigger? It's bigger on the top, so x stays on top. How much bigger? It's bigger by 2, so we use a 2. Next, I'm looking at my y's. All right, again, my y's aren't too bad. I got y to the 5th over y squared. Here's my first question. Where is it bigger? It's bigger on the top. By how much? Well, 5 is 3 more than 2. Okay, so that's my exponent. And finally, z. Nothing's messing with the z. It's going to stay the same, so it's still right there on top. All right, so my missing height, we don't need that one on the bottom anymore, is 8x squared y cubed c. Okay, so remember when you have a word problem where you already have the area, you're probably going to divide to find the missing side. All right, good luck on your exponent division problems.